Good morning, everyone. And welcome to the latest Zero Carbon Mine webinar. I'm Brett Dunstone, and today we've got Peter Wan with us, who is going to be presenting about, accelerating innovation, breaking through the technology adoption sort of barrier, and why it takes so long to implement some of these newer technologies. So, without further ado, I'll sort of hand over to Peter. But if you've got any questions, please put them in the chat, and we'll get to them when we can. Yeah, thanks, Peter. Leave it over to you.
Yes, thanks, Brett, and thanks everybody for taking time out of your day to join, whether it's morning or as it is in British Columbia here, getting into the evening, and it's just about beer o'clock. But I wanted to talk about innovation. Firstly, really at a broader level within mining, and then really zero in on what's the changes, what are we seeing differently in decarbonisation innovation, and what are those barriers that we have to overcome, and the methods that we can adopt to have faster adoption of these technologies. But first of all, I wanted to start off, sorry, let me get my slides moving, there we go. Quickly run through the agenda. So first of all, who am I to talk about innovation? There's a few familiar names in the list that I see, but not everybody. So perhaps just that little bit of a background set, and then a level set on innovation itself, and what are some of the definitions that I think are important to our conversation today, and talk about some of the innovation stories that have happened over the years in mining, how they impact the way that we think about decarb adoption, and what it all means in the big picture. So really, let's start with me. Anybody that does Myers-Briggs would be familiar with the 4 letters acronym that define the type of personality that you are. I come out as an ESTP, extroverted. I do like talking to people. I do like the engagement piece. Problem solver, sensing, thinking, perceiving, adaptable. Lots of the things that we think might be good for working in an innovation role. But that's really just talking about what's your natural or native characteristics and attributes. You still got to develop them yourself. And so I finished university and went out and started doing computer programming, spent a few years there, really built out that logical thinking piece, test plans, troubleshooting, really thinking about what do requirements actually mean, how do you turn them into what you're delivering within a product. Went from there into travel and then into working in mineral exploration. A lot of exposure to different cultures, having to communicate in different ways, and really that adaptability and resilience piece. Things don't always go your way when you're traveling or when you're out in the desert, and you got to do whatever it takes, and really start working out how you communicate, engage with people, and get the best out of the situation. From there, I spent a good 15 years in fleet management in mining operation, or for suppliers to mining operations, and really focusing on technical problem solving, and spent a lot of time working in account management type roles. So working with corporate programs, really understanding what their vision, what their mission was for their particular centers of excellence, and working with them to deliver the results. So very much a results focused, but being able to translate what the user is looking for and deliver that to the team that's actually got to produce the goods. From there, I moved into the mining company side of the world, in essentially an internal consulting role, and I always said that my role there was a translator between miners and technology providers. And I found that often you see that there's a gap between what the miners are asking for and what the technology suppliers are actually hearing and developing in the products. And it's really important at this stage, as we were testing new technologies, to really understand what it means when you say minimum viable product for an innovation product, and how do you bring new suppliers into the industry. They may have great skills in their technical disciplines, but don't necessarily understand how we do it in mining. And I think that's really critical, understanding the environment that they're going to be working in. And in that role, I also spent a lot of time working with industry consortia. So the International Council of Mining Metals, the Global Mining Guidelines Group, working right across industry, mining companies, technology suppliers, OEMs, in different ways. With the ICMM, it was very much around the greenhouse gas working group. So really creating that impetus for development programs within the original equipment manufacturers for zero emission haul trucks and other mining equipment. And then in that journey as well, again, there was lots of technology suppliers coming into the industry, and we almost hosted, or I almost hosted a number of one-on-one sessions for those innovators, really talking through, what the requirements are at the mining level. And that gets into not just the functional requirements of what a product has to provide, but the non-functional requirements in terms of security, timeliness, is it a real-time system? What are the other attributes that make a system usable? And then finally, really working in the decarbonisation world. And again, a lot of communication right from the shop floor right up to the C-suite. So making sure that when we talk to the C-suite, that they really understand the economic drivers of the transition, that we have a really good risk assessment and we're managing the key areas, but then getting down to the shop floor and making sure that, if we're going to put, for example, fast charging technology into the pit, what does that mean to the user that's going to be running the reticulation out to the pit, that's got to manage the transformers and the arc flash hazard and all these things. So I guess what I wanted to communicate in sharing this little piece is that when we think about innovation, we have to think about it differently than we do just day-to-day operations. And it's not always the same skill sets that help you succeed in an operational role as it does with an innovation role. And we'll think about that a little bit more as I get into some of the level set on innovation, and everybody's very familiar with the term innovation, and it's the practical implementation of ideas that result in new goods or services. And often this can be bringing in goods that have been proven or products that have been proven in other industries and applying them to another application, to another vertical. And the key thing about innovation is that it's got to be doable. It's one thing to say that a Tesla is fantastic. It's energy efficient. It's a well-performing vehicle. You may have your personal opinion on that. I apologize, but it's got to be doable when we transition it. So we can't use a Tesla as a haul truck. It's not going to move dirt. So let's make sure that when we think about bringing things from other industries, that it's still got all the practical considerations that make it achievable and it's going to deliver a result. And that's the bottom line for business innovation, is that it's got to be able to produce the results, it's got to deliver the productivity in the case of mining, and it's got to be able to do it at a lower cost of operation than the existing diesel fleet, or it's going to be very challenging to get through with the C-suite. So really that innovative person that we look for in these teams has got to be creative, they've got to be experimental. So one of the big challenges we have in mining is that at its very core, mining is a risk-averse business. We want to manage variation, we want to reduce variation, and we don't want to take risks. And so we've got to be able to have creative people that can think about how we can do things differently. And that's not just the products that we implement, it's not just the truck itself, but it's the people and the processes that support that. So if we transition to fast charging as opposed to fueling a truck with diesel, we've got to make sure that all of our processes manage that effectively so that it can deliver the goods. And we've got to think about those risks and big key risks that we think about in mining. Operational risks. Is it going to be able to achieve the productivity targets? Is it going to achieve them at a lower total cost of business? Commercially, if you're a technology supplier, it's great if you can put a product into the first mine, but is it scalable? Can you get it out to other operations, or is there a huge development curve that is going to allow you to take it into other businesses? And an example of that, when we think about the speed of innovation, is autonomous haulage. It was developed in Western Australia, or primarily for Western Australia and then Chile operations, dry, arid environments. It was well over a decade, probably closer to 15 years before it got implemented into a winter environment, or a northern winter environment in Canada and in Sweden. And there were a lot of challenges associated with that because the product hadn't been delivered in the first case to deal with icy ramps, for dealing with slippery conditions and extreme cold conditions and snow and mud that's going to clog up radar detection and LiDAR detection. So you've got to think about the scalability aspects of your product as well, and it doesn't mean you need it all at the start, but at least be aware of it and manage it. And then there's the financial implications and the investment that goes in and the risk of those projects being unsuccessful. So if you think about trying to sell an innovation project to your chief executive officer or anyone at the executive level, they really want to understand whether this project's going to be successful and whether it fits in with what we have in mining, which is a lot of long life assets and very long mine lives that we're dealing with. So, if you're talking about scaling down your truck size, for example, but you've still got cable shovels and that have an 80-ton bucket, it's going to be a pretty hard sell to tell them that you need to retire an asset of that size and that cost early. So let's talk about a few innovations that have happened in the industry, and one that I wanted to talk about, and really, what I want to talk about is the factors that drove those innovations, whether they were successful or not. And one that I thought of at the outset is differential flotation, which was developed here in British Columbia by what was then Caminco, is now Teck Resources, and it was driven by market need. So the Sullivan mine had basically exhausted its single metal deposits, and it was encountering an ore body that was complex sulfide ores, mixed galena, sphalerite, pyrite, and there was no technology in the day that would be able to separate the lead and the zinc in those ores. And so there was a very experienced research team within Caminco, did a lot of work and identified methods that they could use to selectively manipulate the chemistry and the surface activation and separate the zinc and the lead within a differential flotation process. And so for Caminco in the day, it was very successful, and they were very quickly able to get a dramatic increase in recovery, become extremely profitable. But when we talk about that scalability, that took a lot longer to be adopted by mines worldwide, and for a variety of reasons. Many mines still weren't in that environment where they were having to deal with complex ore bodies, or they had flotation circuits in place that, again, long life assets, it's difficult to just replace that. So, when we look at this first surfacing in 1923, 24, it wasn't until the 40s that it became the universal basis for base metal flotation. So a successful innovation, but not what anybody would say is a fast adoption curve for that innovation. If we get a little bit closer to the meat of what I like to focus on, and that's the fleets within the mine, there's a couple of examples of specialty trucks. And so if I drive across BC a little bit further and I get to Sparwood, I'll see the Terex Titan still parked up proudly out the front of the town. And back in the day, in the early 1970s, it was by far the largest truck in the world, 350 ton, and one of the first diesel electric haul trucks in the world. And it was extremely popular. It had great productivity, but it didn't meet financial hurdles in terms of there were very high maintenance costs, limited parts availability. And so it ultimately was parked up, and Terex did not continue to produce that truck. But what it did do was that it proved the electric drive concept. There were a few others that were around at the time, but it was one of those early prototypes that proved the concept and became what we see today, which is a very large fleet of electric drive trucks from all of the manufacturers. And so really when we think about the driver there was technological innovation or technological opportunity, and perhaps what Terex may have done differently to make that technology adopted more readily and more quickly was think about minimum viable product. What's the scale that's going to be required, and how do I deliver the parts and the maintenance cost that's going to make that successful? There's another truck that is rarely seen. I think I've seen them in Queensland coal and also in coal over here in BC, and that's a crush truck, which if you can see it, it's a belly dumper. It's got 2 axles, and both axles turn when the truck's turning, and so it allows it to operate in very tight areas. And by all accounts, it's loved by the operators that use them. Again, maintenance complexity. And the other aspect here that led to this truck not really scaling and getting adopted worldwide is that it was a private company with limited capital, and really wasn't interested in going sort of mainstream. They really wanted to focus on, engineering challenges and developing specialty trucks for particular use cases. And so when we look at both of those trucks, neither of them are very commonly seen today. But another technological opportunity, and I know Brett's familiar with this one too, we work together there, is dispatch and modular mining systems. And so it was the late 1970s, and Phelps Dodge commissioned research from the University of Arizona to improve truck productivity through an allocation-based system. And so modular mining was formed and developed the dispatch product, which is now basically commonplace in every mine around the world, whether it's Modulus product or Wencos or hexagons or others. But every decent sized mine these days will have a fleet management system, sometimes just tracking, but also sometimes allocating equipment around the world. And the adoption of modular is one that I wanted to touch on a little more because I find it interesting. It was one of those technologies that was very rapidly adopted. And there's a number of reasons for that. One of those is that when modular created the dispatch code, it was essentially open source. And so if we think about Linux and other open source products that are around today, their popularity is that you get this community-driven development. Everybody can contribute, everybody can develop the product to meet their specific needs. So dispatch engineers around the world were developing code that was shared across the customer base. The dispatch engineers and the support staff at Modular were all mining engineers, essentially. And so there was this community that was built, and there was this collaborative environment that was built that allowed something to be developed at a mine in Africa. And very quickly, it would make its way to mines in Australia and South America and North America because there was this collaborative environment. And so you think about modular, it started off in North America, in Arizona, with Phelps Dodge, Arizona and New Mexico. And then they built these regional offices. And these regional offices really accelerated that collaborative environment. The user forums at Modular were legendary, and everybody would get together and have a cracking time. But what they also did was share details of what they had learned, what they had developed, the challenges that they had overcome. And so even today, you run into people that you knew through the dispatch days all around the world. And the network is still strong. And that network really drove that development. What also drove that development was global mining companies and developing corporate programs. So BHP had a centre of excellence. Rio Tinto had a centre of excellence. I worked in a global account management role and worked with, Anglo Gold Ashanti and Freeport and others. And so that meant that you didn't just have collaboration at the regional level. Now all of a sudden there was BHP or Rio Tinto or Freeport operations around the world, and that information and that collaborative network was built all around the world. And so, the terminology that was adopted at one stage there was think local, act global. But really what this did was it did lead to a product that was developed. The company was founded in 1978, 79. The product was really first live in the early 80s. And by the mid 90s, it was truly around the world and thriving. So that is probably one of the fastest technology adoptions that I can think of in the mining industry. If we get a little bit closer to decarbonisation, the other pathway that comes through is competition and Rio Tinto's mine of the future. And I was peripheral to this program, but really fascinated by it at the time and still fascinated by how they achieved this. And what I thought was really compelling about the story of the Rio Tinto mine of the future was that it was executive sponsored, it was executive visioning that started the whole process. And then Rio built this ecosystem of suppliers, and some of them I've been able to capture on the slide, not all of them. And again, I apologise if anybody is slighted by that, but this was a broad program driven by the fact that the iron ore market in the early 2000s was extremely competitive with Rio, BHP, and Vale in particular, but also Fortescue trying to get in on the game, and the need to drive down unit costs and the need to be able to deliver greater selectivity to the customer. And so integrated operations was truly born in mining, I would say, through this program. Integrated planning has become a key aspect of the program, but also autonomous haulage was really proven by Rio Tinto at the level that others then were able to start adopting it with confidence. And so the other aspect of this program, when you think about a single mining company working with a multitude of suppliers, is the financial commitment. Rio Tinto had a lot of skin in this game, and because the program started from that executive sponsorship, they saw what I've said is unwavering financial commitment through the program. There may have been a few hiccups along the road that I'm not aware of, but that's key when you think about these programs are in for the long haul, and you need to make sure that the dollars that you define up front are still going to be available to you by year 3, year 4, year 5, as you're getting deeper into the program. So that's just a quick snapshot of some of the technologies and some of the innovation programs that have happened over recent years. But what are we doing in mining today with respect to fleet decarbonisation? And when we really break it down, there's a few different approaches to it, and they all have merit and they're all worthy of exploring. So the Fortescue Real Zero program is much like the Rio Tinto Mine of the Future program. Single mining company, undoubted executive sponsorship, undoubted financial commitment, and they're going to do it regardless of how high that cost becomes. And so, kudos to Fortescue and to Twiggy Forrest for having that commitment. And a lot of the mining industry is watching keenly. And we will see products come through that program. If they get to Real Zero, even better. If they don't, there'll be products that will be adopted broadly in the industry as well. There's OEM-led consortiums. Caterpillar and Komatsu have taken it slightly differently to the Fortescue program, and I find that this is a really interesting one as well. So with the Caterpillar Early Learner program, for example, I was privy to that program in the early years of it. And what Caterpillar recognized was that here was an opportunity to change the way that they introduce new products, bring customers into the fold much earlier for a number of reasons, voice of the customer, understand the requirements, really elaborate out the plan as they were going. It was a more agile plan than I think anyone would have expected to see from a large OEM. But then just as importantly, bring those customers along so you have some level of comfort that when the product is commercially available, there's a certain number of units going to be out there in the very early years, and they're going to prove the case to all of those that are watching over the fence. So in both of those cases, those products have advanced much quicker than we would typically see trucks being developed. We have prototypes or early learners out in the field now, and the timelines are tight and the timelines have been aggressive, but so far I feel that these programs have been good demonstrations of taking what's an industry-wide need and really driving it to a faster commercial reality. And then the other one, and I've touched on this one already, is industry consortia and things like the ICMM, Global Mining Guidelines working there as well. But the ICMM, I feel that there's credit there for instigating some of the activity that we see in category 2 here, which is the OEM-led consortiums. And so there was really this groundswell coming from the ICMM and market feedback to the OEMs that helped influence the decisions to go ahead with those R&D programs. And the ICMM working group, the GHG working group, also spawned other programs like the Charge On Innovation Challenge and like the program with CharIN to develop an XCMS, so an extended megawatt charging standard specific for the mining and mining environmental conditions. And so these are all great aspects of the broader industry getting together. While I had the privilege of being a co-chair of the GHG working group, I often said that this is the most widely engaging collaboration I've seen in my career in the mining industry. And I think it's really heartening that we would sit in a room and you would have Freeport and Rio and BHP and Teck and Newmont and all these other companies engaging and sharing information that in all other cases, we would have been keeping close to our chest and not sharing. And by doing that, we're all learning from each other. So, we've all advanced our knowledge a lot more quickly than we would have otherwise. So this is all great. There's different models that are being used to accelerate the adoption of technology, but we still got to think about those barriers, and we still got to make sure that new suppliers to the industry understand what our specific barriers are in mining, because they often don't. And that was often part of what I referred to as my mining 101 with technology suppliers is you may do it this way in oil and gas or in rail, but here's what happens in mining and the environment that we have. A quick example of that is with the Caterpillar program when they were first conceiving the idea of the dynamic energy transfer, so the side rail charging system. And we raised concerns that, at our mines in Canada, we could see 2, 3, 4 meter snowpacks developing through the winter, and that the road surfaces were going to be very fragmented, particularly in the spring as everything broke up. And so maintaining a consistent rail height, ensuring that snowpack movements didn't heave and break the rails or the side rail system. And so we said, let's get some of the product and install it alongside a haul road. We're not running any electricity to the rail, but we want to see what the forces are on all of that hardware that we've installed in the ground that's sitting in the snowpack, and we want to understand if it can withstand those conditions. And so that's one of those examples where we need to work together and identify what the challenges are going to be and develop methodologies for overcoming them. But back to the barriers that we see in mining. I've touched on it a couple of times. Mining is such a high capital investment game with long life assets. We're running trucks now that are, running well beyond 100,000 hours. So we've got 15-year assets that now we're saying, can we replace that with a truck that's at a potentially a 2x capital cost? And that's very hard for the financial team or the executive team to approve. Even if we can get past those capital investment hurdles, the regulatory and the permitting timelines are not trivial either. And so again, as we were working through the idea of having an early learner truck in Canada, that regulatory process, there's many people that are probably familiar with the regulatory processes required for autonomous haulage, and this is not dissimilar, but with regulatory bodies that have less understanding of battery electric technologies. And so the process to get through that regulatory process through the development of the project plan were quite extended. And so while we didn't go ahead with the early learner truck, I think we would have been challenged to meet the timelines just based on the work that was laid out in front of us. I've mentioned that mining is a very risk-averse culture, and we strive for reducing variation and repeatability. And so bringing in a new technology, it requires extraordinary diligence on identifying risk and managing risk with people and process in particular. And so how do we do things differently? And how do we manage that difference and the change management that goes along with that? It's interesting, and it's something that's not often talked about, that we think about autonomous haulage, and the initial cases of autonomous haulage were often in remote fly in, fly out operations where a certain portion of the value case was generated through the cost of having operators fly to site, camp in site, and so on. When you don't have that in there, it becomes much more focused on what the productivity of the trucks is. And in cases we see where processes don't change, and you have, for example, a water truck or a fuel delivery that has to run through the autonomous haul zone, and it shuts down the whole operation while it goes through. And so just managing that variability of process and adapting processes so that we can manage in a different way are big challenges to overcome. Market fragmentation is a real one too, and I've talked about it briefly just in the sense of autonomous haulage was implemented for desert, dry operations. And then we have to think about bringing in snowy conditions, icy conditions, different subarctic conditions where the temperatures and particularly as that applies to batteries become very critical as well. And so we need to be very aware of that. Going back to the Caterpillar Early Learner program, that was one of the reasons why I was particularly keen to see a range of operators involved in that program, not just Pilbara, Chile, even Brazil, but we needed to see operators that were going to be operating in mountainous terrain, like Newmont is in Colorado. We needed to see it in very cold conditions, and we see Boliden operating autonomous haulage up in northern Sweden. So it's really important that if you're a technology supplier, that you think about what that scale up is going to look like for you, and that you bring in voice of the customer input in all those regions and all those different market sectors that may have different conditions that you need to plan for. Technology integration is not to be underrated either. When we think about the level of technology that we have in mines today and how you've got to implement your solutions so that they sit alongside all of those other products and they integrate well. So even when we think about fleet decarbonisation, for example, and we want to start doing simulation so that we can do our trade-off studies between the diesel electric fleet and the battery electric fleet, we need to make sure that that simulation has the ability to integrate with your mine planning system so that your mine planning teams are not having to do a significant amount of rework just in order to be able to run for a battery electric fleet. We deploy the technology, we deploy the battery electric trucks. We need to make sure that they can integrate with our autonomous haulage, with our fleet management system. If we're integrating with fleet management system, does it have an energy management module that is going to ensure that we can understand the state of charge of the trucks and we can deliver the right trucks to the chargers so that they're not queuing at a charger and that they're getting the charge that they need in a timely way, that we're optimizing battery life by not drawing them down too low, not charging them up so high that we're going to have any thermal degradation and so on. And then we really need to make sure that we understand profitability. The one that I haven't called out specifically, but that goes really hand in hand there as well, and also fits with risk, is the health and safety aspect. And this was one of the points that really came out of some of the collaborative consortium work that's been done over the last half dozen years around electrical safety, arc flash safety, and it's at a level that probably hadn't been appreciated by all in the industry. And I think that collaboration has done a great job of communicating that out to the broader masses. So what does it all mean? If I try to distill it down into a number of steps or a checklist that we can take to make sure we're setting up our innovation programs for success, we have to make sure that we start with the vision. What are we actually trying to achieve and for whom? And again, this applies to both mining companies and technology suppliers. If you're trying to create it for yourself as a mining company, make sure that you've got all of the appropriate people in your team. If you're a technology supplier, do you have the reach into industry so you understand the needs of the industry and you're really building that into your requirements definitions? I can't understate this one. Innovation happens at the speed of trust. When we have trusting, collaborative relationships with our suppliers, with our partners, things can bend but not break. And so I used to have a goal when I was working in fleet management, was that we would negotiate an agreement, and ideally, once we'd executed and signed the agreement, it would be put on the shelf and we wouldn't reference it again, because we had a common understanding of what we were trying to achieve. We had talked through the process, so we understood what the non-negotiables were for each of the parties. There's some things that are truly non-negotiables. A supplier cannot provide certain things, a mining company likewise, and we need to understand that, so that when we get to the table, when something goes slightly sideways, as they always do in innovation programs, we understand how we're going to correct the course and move on together. I touched on this one. Does your innovation ecosystem include all of the parties you need? And when we think about fleet decarbonisation, we're not just talking about the trucks. We're talking about the batteries. We're talking about the electrical charging infrastructure, and all of the aspects. If it's hydrogen production and hydrogen storage and all of those aspects. Do we have all of the partners that we need? And if you're a technology supplier, your innovation ecosystem includes those customers that are working in the different market sectors that you want to actually get adoption in. It also includes any other technology partners that you're going to have to integrate with. If you're that simulation tool and you've got to simulate with mine planning software or fleet management software, make sure that those stakeholders are in your ecosystem as well. Define the model that you're going to follow for the innovation rollout. Who does what? But just as importantly, or maybe more importantly, what's in it for me, for every stakeholder that's playing in the game. Everybody has to have something that they want to achieve out of this project, and we've got to make sure that everyone gets their just rewards. So it's got to be a win-win. We're not doing this so that one company is achieving everything at once and the others are left unsatisfied, because when we get to scale and we get to adoption, we need everybody to still be viable entities that can keep this moving forward. And make sure remember that it's an innovation project. We're going into somewhat of the unknown, and we need to make sure that our stage gates are really defined with learning objectives. As we hit each stage gate, what have we learned and what do we need to change in the process? So I've been involved in innovation projects where we truly didn't know what we were going to achieve by stage gate 1 or 2 or 3 when we were negotiating the agreement. So we built into the process that we would set the metrics for each of those stage gates prior to the test or the proving, the validation step. And then we would move through the stage gate with an agreed approach to correcting any of the variations, and repeat that process again. So before we get to the next stage gate, well, what do we know now? What has changed, and how are we going to do this? And you need to be agile. You need to make sure that you recognize and you bring those concerns to attention. So if one stakeholder, for example, realizes that we're going to have a throughput problem, whether that's electrical or whether that's data that's going to impact the project, it's really important that that gets brought forward, and that there's a collaborative problem-solving approach to it so that everybody can pivot together and keep moving forward. And communicate. Communicate, communicate, communicate. And communication is not just talking, it's listening. And even with the best of intentions, we sometimes fail at this. And I've been involved in a project just very recently where we got to the delivery to the executive team, and we had not brought them along enough on the journey. So it was a lot of information, and we didn't have all of their questions answered because we had not done that communication. So it's really important you bring everybody along on the journey and you unearth any of those concerns, any of those potential barriers early, so that you've got time to address them, and not have a surprise when you're sitting at the boardroom table trying to get your project across the line. So in conclusion, the energy transition is driving the next wave of industrial innovation, and these solutions are evolving quickly, and they're evolving in markets that we don't typically look at, but we're starting to do so now because everybody's trying to solve this decarbonisation problem. So as you look at solutions from other industries, don't be scared of them, but make sure that you have that measured assessment of whether they're suitable for our market and what needs to be done to make them suitable and doable if we think back to the definitions. I said it earlier and I'll say it again, the industry collaboration on decarbonisation has been at an all-time high, but we need to make sure that we keep that conversation flowing, that everybody builds their networks, and we learn by what everybody's doing. There's a lot of power in learn by doing. There's also a lot of power by learn by talking to those that are doing and really fostering those relationships. And plan to succeed. Make sure that you've got your executive commitment. Make sure you're explicit with the scope, that you've got a full and complementary ecosystem that's going to support the project and get wins from the project themselves, and learn by doing. Be prepared to recognize that something didn't go exactly as planned, adjust, and keep moving forward. Because that's the secret sauce. We've got to have diverse skills. We've got to have communication, creativity, and we've got to make sure that we open up an environment that's trusting, it's flexible, and there's no egos. If you identify a problem and it's with your own product or your own part of the pie, put your hand up, make sure that everyone's aware of it so that we can solve it together and keep moving forward. So that's all I've got for you. Happy to have discussions, questions, or just broader thoughts and ways that we can keep moving forward, because this innovation is critical and we need to move it at pace. So thank you very much.
Thanks, Pete. No, that's a lot of information there. A lot to digest, but yeah, at least there's a bit of a path forward. If anyone's got any questions, please drop them in the chat, and we'll try to get to them. I suppose one I have is like, you've sort of given us a bit of a path on what we need to do, but do you think, to achieve the sort of targets industry's set or whatever, do you think we're going to get there with how we're going at the moment?
I think there's a lot of rationalization going on, and I think that a lot of that early enthusiasm gets tempered by, the financial, the numbers that are being presented, but also by the risk management, and again, thinking about trying to reduce variability, and we don't want upset events. So I think that things are scaling back to a level, and once those first units are out there and proving that they can achieve the quality, the production, and the cost, then I think we will see a fairly rapid acceleration. But whether the 2030 targets are met, I think we'll see also that mines are pivoting to low capital projects to achieve the 2030 target, and renewables have been reducing cost and so effective that that's an easy pathway, and it reduces the risk. So we'll see that, and we'll see the fleet slowed down somewhat, but still progressing.
Right.
Sorry, I see a question on the chat there from Marshall about our team has performed circular mining with biochar and pyrolysis. Are you aware of this approach? I am. I could take a stab at where you're from, Marshall, but I will say that I've talked to former colleagues that are still involved in biochar in particular, and from my understanding, first trials have been successful with that, which is very positive. Again, low capital approach, and it's reducing operating costs, so that's a very effective strategy. The pyrolysis we looked at in quite a lot of detail. The challenge for me with pyrolysis, and as it related to pyrolysis for production of hydrogen, was that you still had the really high hurdle of the cost of the hydrogen storage infrastructure to overcome. So the hydrogen production technology looks sound, but the storage is just such a challenge to overcome.
And you'll be able to provide this your slides for people?
Yeah, absolutely. I'll send them to you, Brett, for circulation, or is that the way that you typically go?
Yep. No, that's fine. Yeah.
Yep. Okay. Yeah. Well,
yeah.
If there's no other questions, thanks everybody. I appreciate your time.
Yeah.
I hope that collaboration keeps going so that I can put faces to names as we move forward, and we all work together.
Thank you, Pete. I've dropped a survey in the chat box, the chat, just to get feedback on the webinars and what people want to see and that sort of thing. So any can fill that out. Got a chance? Let us know. Your thoughts. Be appreciated and what we can deliver next year. So yeah. But if there's no other questions, I'll leave it there. And thank you, Pete. And I'll let you get on. Well, your evening now, I suppose.
Thanks, everybody.